All right, good morning, good evening again, students. As I sent in a message, we have the class will be broken up into two sessions. The first one, which is between 5 p.m. and 6:45. We're going to do the IGCSE students. Same paper we started last week, and from 6:45 to 8 p.m. the C6 we'll be doing January 20 paper 1, 2019 paper 1. All right, so we're gonna but I won't continue. I'm going to recap for those who missed out last week session. We're gonna do that paper, and then next week for his IGC students, we'll be doing a paper 3, which will be a sample paper for 2020. Good. So for the IGC students, we'll be dealing with you first. We'll work on the paper. It should be a browse through since we have already done the first 3 questions so far. Nevertheless, we'll do it over so you have a better idea to where we messed up. Good. So nice. So IGC students, everybody hearing me good? You could post on the chat so I'll have an idea. Everyone hear me okay so far, right? So Jenna there, good, nice. David, I hope there are others who would come in as well, so we could follow up. Good. So the question here in question 1, we did this last week, but we browse through fast since it had been posted on whatever media for students to see over the paper. So the question here says in figure 1.1 shows the speed time graph for a car traveling along a straight road. For the CXC students, for the CXC students, you could start the multiple choice paper in January 2019 multiple choice paper. So the time we're ready to start, which is around 6:45, is just for it to continue. For IGC students, we continue with this paper from last week. So they said here in the question, they said figure 1.1 shows the speed time graph of a car traveling along a straight road. The graph shows how the speed of the car changes as the car passes through a small town. So the town is between B and C. He enters at point B and leaves at C. The question here says calculate the distance between the start of the town and the end of the town. So he enters the town at B and leaves the town at C. So we need to calculate the distance. So we're calculating distance in a speed time graph. The distance is equivalent to length by breadth, which is the area underneath the graph. Good. What we would have done is the area of a rectangle. Good. Which is here. Good. So for the speed time graph, you use this here. Speed here, the time here. So this is your graph. We are asking you to calculate here. So you're going to obviously have a speed here, and you're going to have a T1 and a T2. Good, so you're going to be the distance between here is the area covered in the graph. Good. So the distance is equals to speed multiplied by time. Or if you want to use the area of a rectangle is length by breadth. So your length is going to be your time and your breadth is going to be your speed. Good. So you're going to have a S1 here and a S2 here. Two different. So they're going to be at 0.0. So which is equal to the distance is equal to the first speed, which is 0. If we go back to our graph, all right, if we go back to our graph here, watch here, this whole measurement here, So this whole diagram, this whole measurement here we check in. Right, so it's between point B and point C. That's what we're concerned about, right? Right, so your first one is here, and the second one is here, and here. So your S1 is what value? Your S1 is here, your S2 is here, your T1 is here, and your T2 is here. Good, your T1 value is if we check it, here's 10, here's 10, here's 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we have 18 here. So your T1 is basically 18 seconds, and your T2 is 40, 41, 42. So you get T2 is 42. Well, so here going to be 42 seconds. And S1 is 0 meter per second. And S2 is, we go to S2. So here's 10. Here going to be 11. Here going to be 11. So 10, 10.5, 11, 11.5, 12, 12.5, 13. The answer is 13 here, which is 13 meter per second. So it's 0 and 13 and 18 and 42. Good? Good? So we're going to use those two values now on the graph, the whiteboard here to calculate. So you're going to be, your speed was what? 13 minus 0, that's meter per second, multiply by your time. Your time difference was 42 minus 18, and it is in seconds. The 2 seconds calculate. So 13 minus 0 is 13 meters, multiplied by 42 minus 18 is how much? How much we had calculated 42 minus 18 was? I think we did this. So 42 minus 18 is 24. So 24 multiplied by 32 is approximately, multiplied by 13 is 312. So you're supposed to get 312 meters. So that should be a distance when you enter the tongue that's at point B and you leave at point C. Good, everyone okay with that so far? This is just a recap from last week's sessions. You need to type my yes so I have an idea to move on. For those here, all okay with that so far? Good, nice. So we're moving on to the next part of the question. So they say calculate the acceleration between C and D. So C is here and D is here now. So we're going to look for these two values. So point C was what? We know that the acceleration is speed over time, right? It should have been velocity over time. So we're going to check these two values here. The first one here is D, and at point D, what value is that? But we understand the value at point C. Let's see if I can make this a bit small. Right. So this is point D here. This is point C here. This is point C here. Right. So those are the two values. Good. So here's S1. So here's S1. Here's S2. Here's T1. And here's T2. We need to find this value here was how much? We calculated to be 13 meter per second. So here's 30, 30.0 and 31. So here's 31 meter per second. Here is T1. T1 was 42 seconds. And T3 is, that's at point D, it will be 50. Here's 50. Here's 50. Here's 51, 52, 53, 54. Alright, so here's 54, which is 54 on the side here. So 54 meter per second. So sorry, not meter per second, 4 seconds. Good. So they ask us to calculate the acceleration. So we're going to calculate the acceleration from that now. How we're going to do that? We obviously going to use clean out this here. Alright, so this is our another graph. This is the same graph. I just drawing a simplified version. So you have point C. Yeah. And point D. So this is point C, this is point D. Here is 42 seconds. Here's 54 seconds. Here's 13 meter per second. And here's 31 is 51 meter per second. So speed is time. Good, so we're going to calculate acceleration. So acceleration is equal to change in speed over change in time. Should have been change in velocity. All right. Remember, acceleration is the rate of change of velocity, but we're going to equate the speed with velocity because the bus is moving out item and turn in a particular direction. So you're going to be change in speed. So you're going to be S2 minus S1 over T2 minus T1. Your S2 was what value? 31 minus 13. Your overall unit is meter per second over 54 minus 42 seconds. So we're going to work on that, which is 31 minus 13 divided by open brackets 54 minus 42 close brackets. Your answer is 1.5 meter per second squared. Why we use meter per second squared? Because that's the unit of acceleration. And besides the s here, what the s here, and this s here going to multiply each other. When they multiply the same variable, it is squared top off. All right. Good. So everybody okay with this so far? Are you okay with this so far? Nice. So we're moving on. So we calculate the acceleration. Now they had asked, now lower down, state how the graph shows the deceleration of the car has the same numerical value as the acceleration. State how the graph shows the deceleration of the car has the same numerical value. So if the deceleration of the car has the same numerical value, this means, this is important here, state how the graph shows. How the graph shows that? Because the graph has the same steepness again. So So we are going to say that the graph has the same slope for both deceleration, acceleration, and acceleration. Good. That's basically it, and we can calculate it using the two values on the graph here between point A and point B, as I showed you last week, and you could calculate it. Your distance value was 312 meter. K was 1.5 meter per second squared. Good. And the graph has the same slope for both deceleration and acceleration. Everyone okay with that? And we can move on to question 2. Guys, you can move on. Nice. So moving on to question 2 now. They said here, in this question, they said figure 2.1 shows a conveyor belt transporting a package to a raised platform. The belt is driven by a motor. The package has a mass of this value, so this is the mass of the package, 36 kilogram. Calculate the increase in gravitational potential energy. So your gravitational potential energy is this formula here. So potential energy, or we just call it EP, right, is equals the mass by gravity by height. So EP is equals to your mass, which is 36 kilogram. We know that gravity, we use gravity as being 10 newtons per kilogram in IGCSE, and your height, that's what we need to calculate. We need to see what that is. So we go to the height now. They said that the gravitational calculate the increase in the potential energy of the package when it is raised to a vertical height of 2.4. So this is your mass, this is your height, and we know that G is 10 Newton per kilogram. Good. So we're going to use 2.4 meters. So we're going to calculate the units to Newton meters. EP, or potential energy, is equal to 36 multiplied by 10 multiplied by 2.4, which is 864 Newton meter, right? So 864 Newton meter. Also, one thing to note, the unit for potential energy we know is joules. So we can safely say that so we could say that note 1 Newton meter is equivalent to the same thing as 1 joule. Good, something important to note. Yeah, all right. So 1 Newton meter is equal to 1 joule. So your other answer should be, if you wanted to put 864 joules, your answer would have been the same. Good. So take down that. That's to calculate for potential energy. Everybody okay with us so far? Nice. So moving on. Light speed ahead. So good. So your answer was 864 joules here. Good. They said now the package is raised through the vertical height of 2.4 in 4.4 seconds. Calculate the power required to raise the package. So they now give us something new. The new things that they give us here is time. How we calculating time? How we calculating energy? Energy is power divided by, power is energy divided by time. Good? So you're gonna say power is equals to energy, which is EP or potential energy divided by time. So if it's energy by time, the only energy that we had was potential energy, or potential energy was 864 joules over your time was 4.4 seconds. So 864 divided by 4.4 seconds, which is 196.4. Since this power, your unit would be joule per second, or if you want, what you could note here, note that 1 joule is equal to 1 joule per second is equivalent to 1 watt. Then, important thing to note, so if you have 196.4 watts, it is the same answer. Then, so those are the two answers you should have. Stick down that and then we're going to move forward. Good, so you can move forward. Can we? Nice. So the question here says in part C, they said the electrical power supplied to the motor is much greater than the answer. So instead of supplying 364 to the motor, we have to supply, using a random value, probably 900. They're asking, explain how the principle of conservation of energy applies to the system. So we would have learned that the principle of energy states that energy is, since energy is neither created nor destroyed, but changes from one form to another, this means that some of the electrical power supplied to the motor would have been converted to thermal energy generated from the heating of the belt and motor windings. Again, so the energy is neither created nor destroyed. So what happened is you supply 900. Out of the 900, 864 is used by the motor. The other 36 is lost through the heat formed, the thermal energy formed from the heating of the belt and motor windings. Good? You move on. But if you add this heat energy and you add the energy, so the electrical power supplied to the motor, then definitely you're going to amount to the amount. You're going to total the amount that is supplied at the beginning. Okay, everybody okay now so far? Nice. We're moving on. They said here in the question, they said assume the power available to raise packages is constant. So the power to raise the package is constant. The package of a mass of a mass greater than 36 kg is raised through the same height. Suggest and explain the effect of this increase in mass on the operation of the conveyor belt. So, we go back to the board here. All right, so let's see. The since they said that the power is the same, so what we learned so far is that your mass is in your potential energy. Good. So if your mass increase, your potential energy going to increase. However, we also know that power is equivalent. We also know that is power is equivalent to energy over time. So if we say that your energy increases, but this remains one value, the power remains one value, what is going to happen to the time? The time, obviously, if you're going to change around this formula here, T is equals to potential energy over power. So if your potential energy increased and your power stay the same, that means your time is going to increase as well. So if your package is heavier, so let's say here explain, suggest and explain the effects of the increase in mass of the operation. Increase in mass means that the potential energy will increase. Good. If the potential energy, however, if the power is constant, this means, all right, as the last line, so the potential energy will increase. Good. So if we know that the potential energy going to increase and your power is constant, however, if the power is constant, if the power is constant, if the power is constant the and the potential energy increases, this means that it will take a longer time to move the package on the conveyor belt. Okay, everybody understand on the conveyor? Everybody understand how we get it? If you relate it back to here, I'm going to show you on the whiteboard. So if the first one, right, if the first one here is mass, if mass increase, so I'm going to show you back to the original formula. So here, potential energy is equals to mass by gravity by height. If your mass increase, your potential energy is going to increase. Good. Gravity is constant. We know that. Since gravity is constant, we cannot do anything with gravity because as one constant we can't change unless we change from going from the earth to the moon where gravity is much lower. Good. So if your mass increase, your potential energy is going to increase. But if the power here stays constant and you change the formula to suit this here time, so we're going to use the same formula. Power is energy over time. We want to calculate for T. So T is equals to energy over power. If your energy increases and your power remains the same, that means your time will increase as well. Good. So it will take longer for the package to go up the conveyor belt. Alright, so this is how we relate the explanation that we have. See if you don't get, see if you have an idea. Right. So we're moving forward. We can move forward, right? Yeah. So nice. So number 3 now in question 3. Question 3 here says the train of an the train of an unpowered the engine of an unpowered toy train is rolling at a constant speed on a level track as shown in figure 3.1. So you have a stationary track here and this engine is going to collide with the stationary track. Stationary track means that your velocity is going to be 0. Good. They ask you to calculate. So they ask you to calculate here the momentum of the toy engine. That's this one that's moving. Good. So your toy engine has a speed of, so here is your speed, which is velocity, and here is your mass. Momentum, which is a funny shape P. Momentum is equals to mass by velocity. Your mass was how much? 0.50 kilogram multiplied by 0.32 meter per second. So we are going to use to calculate that here. So 0.50 multiplied by 0.32, your 32, sorry, 0.5 multiplied by 0.32, you get 0.16 meter kilogram. The unit will be kilogram meter per second as a unit for momentum. Good? Everyone okay with that so far? So we get the momentum of the train. Nice. So we're moving on. Excellent. So we're moving on. What we know so far is that V here in this scenario, since it's a stationary train, your V is 0 meter per second here. Good. We're going to call this V2. We're going to call this here V1. We're going to call this here mass 1. And now we're going to calculate for the below. So moving forward. Question here says the mass of the truck is 0.30 kilogram. They ask you to calculate the speed of the joint engine and truck immediately after collision. So they stick together. So this moving engine hit this stationary truck and stick together and they never move. No, they move, but we don't know what is the speed. But remember this was stationary. So the formula you're going to use for this here is is good. So we're going to use M1 V1 plus M2 V2, which is equals to M1 plus V1. Sorry, not V1. M1 plus M2, and they stick together. So we're going to label that as U. So M1 V1 was the momentum of the first vehicle, which would have been, when you work on M1 V1, it would have been 0.5 multiplied by 0.32, and we would have known that to be a value. And the second one would have been mass, the mass of the truck, which is M2. The stationary truck is 0.30 multiplied by what speed? Remember, it was stationary, to be 0, is equals to 0.5, the mass of the first one, plus the mass of the second one, multiplied by U. Anything multiplied by 0 is itself, so when we work on this, we get 0.16 kilogram meter per second is equals to, when you add these two values, 0.5 and 0.3, you get 0.8 kilogram. Good, and you're multiplying that by U. So we want to make U the subject of the formula. How we're going to do that is going to use our next screen for you to see here. So how we're going to do that is we're going to use the 0.16 kilogram meter per second divided by, since it was on the the right hand side, the first it becomes and divided by, so it's going to be 0.8 kilogram, and that is U. Kilograms will cancel, so 0.16 divided by 0.8, you should get 0.2 meter per second as a velocity. Good, and we label that as U. Everyone okay with that so far? So your answer should be 0.2 meter per second. So the truck, the moving toy engine, was moving at a momentum of 0.16 kilogram per second. It hits the stationary truck would have a momentum of 0 because it was not moving. You would only get a momentum if the object is moving. So when it hit the object, the stationary truck here should move forward and hit the stationary truck. When it hit the stationary truck, it drags the stationary truck in the direction it is moving at a velocity of 0.2 meter per second. Everybody okay with that so far? Are you okay with that so far, or I should take off the working? Good, nice. So nice. So your first answer for momentum here was 0.16, right, kilogram meter per second. The second one here was 0.2, no, was 0.2 meter per second. All right, meter per second. We're going down again. It said now, so that was question 3. We're going to question 4 now. Good. So question 4 here, they said a solar panel is mounted on the roof of a house. Figure 4.1 shows the section through the solar panel. So this is your sunlight coming. This is a glass sheet. Metal. This is a metal backing sheet painted black. This is the insulating material inside it. This is your water here, and this is trapped air. And this is conductive pipe. So water will be flowing into the pipe, and it will heat up the water. Okay? They said the pump makes water flow through copper pipes. The water is heated by passing through the solar panel. A. Select and explain 3 features of the solar panel that maximizes the final temperature of the water. What is the first thing we notice about the solar panel here? This solar panel is for the heating, so it's supposed to be called a solar water heater. This is exactly what it should be, and it's mounted at the top of a roof in which it heats water and pumps it to the house. So it have copper tubings, it have insulating material, and it is painted black. It have glass sheeting and it's trapped air. So they are asking here, state 3 features of the solar water heater or solar panel that maximizes the final temperature of water. Good. Right, so the first one we're talking about is the insulating material. Why we use an insulating material? The insulating material will do what? What will the insulating material do? What do you think the insulating material will do? Right, it would trap the heat and keep it good, so it would reduce So it will trap the heat and keep it. So the insulating material will reduce heat loss. Heat loss. So the insulating material will reduce heat loss or prevent. Sorry, will prevent heat loss. Prevent or reduce. Anyone you want to use? So I'm going to use both. Prevent or reduce. Reduce heat loss. Heat loss in the panel, right? So that's the first one we would want to use. So the insulating material. What is the next thing that that we could talk about? So the insulating material will reduce heat loss. The first one. Again, anybody have any idea what we could talk about? Again, the next one. Why does the back end is painted black? It have a reason why the back end is painted black. What happens, right? Why it is painted black? Anybody have an idea why it is painted black? The metal backing. Right, good, excellent. To take in heat or to absorb heat. Good. So the metal backing sheet is painted black. Is painted black. Is painted black. Is painted black so as to absorb most heat. Good. Remember, black absorbs heat, so it's a good absorber of heat. So as to absorb the most heat. All right. So that is why the paint the metal backing sheet is painted black so as to absorb the most heat. So as to the absorb maximum heat again. Right. The next one, what is the next thing? So we have the insulating material, we have the metal backing sheet painted. Why we use copper pipes? And the copper pipe is painted black. Why we use copper pipes? Right, good. Somebody said we use it. Why we use the copper pipes painted black? Why do you think? Good. So the good at conducting is a good thermal conductor. Copper is a good thermal conductor. So copper pipes painted in black. Right? So copper pipes painted black is a good conductor of heat, or we can say is a good thermal conductor of both heat and heat. But we're not focusing on the electricity feed here right now. We're focusing on the heat or thermal energy. So this is 3. If you want an extra one, we could also talk about your the glass. Why we use glass sheet in here? The glass sheet is the glass sheet. I'll give you an next answer just in case I ask you for next time. The glass sheet and produces the greenhouse effect, which means that that it well, like it just say the greenhouse effect. With the greenhouse effect, what happens is it blocks the the short wavelengths and allow the long ones to pass through. So that's which means that they block off some of the radiation and allowing some to go, right? So you can just leave it as that it produces the greenhouse effect, and you can look upon the greenhouse effect. Then, so those are the, well, they ask you a 3, I give you a 4, so just in case. Alright, so you're moving on. We can move on now. Could we? Yeah. Good. Nice, so moving on. They said here now, okay. They said here on in during one day 250 kilograms of water is pumped through the solar panel. The temperature of this water rises to 16 degrees from 38. Rises from 16 to 38, so it goes from a lower to high. The water absorbs 25% of the energy incident on the solar panel. The specific heat capacity of water is 4200 joules kilogram Celsius. So the energy incident on the solar panel during the day. So let's go back here. So let me see where's the information they give us here. So the first thing they give us is the mass of the water. Then the second thing they give us is T2. First thing they give us T1 here. They also talk about your specific heat capacity, which is C. Then and they said that the energy, the water absorbs 25% of the energy incident on the solar panel. So that means your solar panel that means that your, we calculate, so we know that Q is equals to MC delta theta. So we're going to call the two temperatures. Instead of T1, I'm going to use theta 1 and theta 2 because we have learned that. So here's theta 1, here's theta 2. So your mass of your water was 250 kilogram. Your specific heat capacity of water is 4200 joules per kilogram degree C. Your two temperatures is going to be, you went to 38 from 16 degrees C. The units going to cancel, so you end up with joules. Now mind you hear what they said. They said that the water absorbed 25% of the energy. All right, 25% of the energy on the solar panel. So they are asking us to calculate now the energy incident on the solar panel. So read back this so you understand. The water absorbs 25. So 25% is basically a quarter of the energy. So the energy here is a quarter. So we know so far that this energy that we're going to get here, when you work it out, it's going to be energy is quarter of the value, or 20. You know what? I'll put it as 25%. So write that in. So 25% of Q, and we're going to call Q your value for the incident on the solar panel. Good. This is the Q for the solar panel because we know that Q is MC delta theta. However, we know that it's 25% to get this value. So you're going to be 250 multiplied by 4200 multiplied by the difference between 38 and 16, which is one big number, which is, I'll put in back this, 25% of Q would give it a value which is 2, 3, 1, 1, 2, 3, 4, 5, 5 zeros. So that's the big number I get here. Now, if we want to find 25%, so you want to find the actual Q. We're going to find the actual Q now. I'm going to write it on a whiteboard one side. So here, if we're going to find the actual value, so 25% of Q is equals to 231 joules. So you want to find Q. So Q is equals to 231 joules divided by 25%. So Q is equals to, because remember this dot means to multiply, right, between 25% and the Q. You divide by that value divided by 25%. So you should get a value of 924 joules. So if you notice, you get 924 and 5 zeros after, which we could say is 92.4 megajoules is supplied to the solar panel. However, the water only uses 23.1 megajoules. The others is lost through some way. Well, it isn't really lost, it's converted to something else. Good, so everybody okay with that so far? Everyone okay with that so far? Nice. You don't need to convert it once you use the number as zeros. That's fine. Once you have the correct working, that's all that matters, and the exact zeros. Good. So your answer for this should have been 9343431. Let's check on the shade tree. 924, sorry. So your answer should be this here. 924 joules. Well, it's the same thing as saying 92.4 megajoules. Alright, so everybody okay with that so far? Well, I've given it the working, so you see. Right, the question was asked to say, how can it be more than the original? Your original value is this value. That is what they are asking you to find. The energy on the energy they're asking you to find this here. The energy incident on the solar panel. We only know the energy, we calculate the energy of the water to be what value? The water to be 223.1 megajoules. We had calculated to be that. However, they said that this value here is only quarter of the amount that is supplied to the panel. So if it's just quarter the amount, or 25%, then obviously it's going to have to be more. So you multiply this value by 4. You could just simply multiply this value by 4 right here, which you should get. If you put 23.1 multiplied by 4, the same value you get, which is 92.4 megajoules. It must be more. your original value going to always be more, because the original value is the one that comes into the solar panel, not the one that we calculate from the water. The one that we calculate from the water is just quarter the amount. Good? Because some of it going to be lost through heat and some other things. Okay with that, Christian? Yeah, the divide sign under the 23.1 from here, I'm going to show you. From here means that this value was quarter. So quarter of the amount that coming into the, so here, quarter of the amount here, which is 25%, multiplied by the amount that comes in to the solar panel. We don't know that amount, but we know that this whole value here is the amount that gives you the water, because the water is quarter of the amount that coming from the sun. So we just take this 25% and carry it across, because I multiply, you're going to divide. So Q, which is the amount that comes in to the solar panel, is really the amount by the water divided by 25% of it, because it was quarter of the amount. Good. If you wanted to use multiply by 4, nothing wrong with it. Anyhow, that's why I choose to do it that way when you ask the question again. You okay with that so far? Nice. So you're moving forward. Nice. So they ask us now. Yeah. They said lower down the solar panel. They said the solar panel in figure 4.1 is designed to heat water. We know that, right? A person is deciding whether to install solar panels on a home. List and explain 3 pieces of information she needs to consider in order to make a decision. All right. So first thing first, if you have to use the solar panel, your roof must be in a particular position to get maximum heating. It must be 10 degrees. 10 degrees. Well, it depends on the geographical location. For us, it's 10 degrees. On the, I can't remember exactly which side, but 10 degrees. So it had to be basically the position of your roof, because you don't want to connect a solar panel. And when the sunrise, normally sunrise on the east and sets on the west. When it rises on the east only on midday, then you're able to get some sunlight to the solar panel. So the first consideration you must take, the first thing you must take into consideration is the direction the roof of house faces. Alright, the direction the roof of the house faces. The second one would be what could hinder this thing. So the next one could be if the direction of the roof of the house. The second one could be listen, I think 3 pieces of information need to consider. If the roof, whether the roof is shaded, If the roof is shaded, that means no sunlight is going to hit the solar panels. So definitely it makes no sense to use the solar panels. Third one you could think about. The third one she could think about is the cost of the panel and installation. It makes no sense. The cost of panel and installation. It makes no sense that she decides to do this and it will cost so far cheaper to just use a shower head rather than a solar water heater. All right, so because of the solar panel and its installation. Good, there's another thing, because when you go to do any form of installation, obviously you check the pricing against thing. For people who do, like, for example, the aftermarket CNG kit installation, what they normally do, but people who decide to do it, they would check to see the mileage they cover of a particular period and the cost for the gas for that mileage. If it's much easier, better just output the capital to put on the CNG kit and run lower rather than to continuously pay the gas at a higher rate. It's the same thing that was explained here with the cost of the solar panel. If you feel that you need hot water all the time and you need that's not going to be in a demand, then obviously it would be necessary that you spend the capital to do solar water heating rather than consistently use electric heating of water. Okay. Another thing to note is that if you plan to use the solar water heating in our country, well, this is just standard knowledge that the government give you a quarter of the value tax break. So if you spend 10,000, then obviously you're gonna get tax rate of 2,500. You're gonna get back that. Good. So they go put a subsidy of three-quarter the amount. Good. Another reason I just giving you a fourth one would be remember I was talking about if the water heat if hot water is going to be required all the time. If the hot water is only going to be required just for the night time, better just put on a shower here rather than to spend all of the money and not use it all the time. So as if you're going to use the hot water is going to be required all the time and for the amount of usage. Then everybody okay with that so far? I just give an extra one so just in case. Are you okay with that? Nice. So those are the four answers that I think would be suitable to it. Right. Going on again. Listen in part D. Part D of the question is the sun releases energy as a result of nuclear fusion. What is nuclear fusion? Nuclear fusion is the joining of is when nuclei nuclei is more than one join together and accepts the hydrogen for the nuclei to produce a different element. Good, which is what we did in radioactivity. Remember we did alpha decay and so for the similar. Nuclear fusion is basically when two nuclei join together and accepts the hydrogen for a nuclei to produce a different element. Which one of them accept a hydrogen is alpha decay, right? Similar to that. So that's nuclear fusion. So everybody okay with that part so far? Nice. So moving on. It said here, figure 5.1 shows a gas contained in a cylinder enclosed by piston, pressure gas cylinder, whatever. So this is the length of it. They said at first the length of the gas cylinder containing the gas is 100 centimeter. The pressure of the gas shown by the pressure gauge is 300 kilopascal. The area in the cross-sectional section of the cylinder is 0.2 meter per second. It said describe the motion of the particles of the gas. And we would have done this before. How this actually happens is that going back to our note, we did this in thermal. Right, so they're asking me any question. Describe the motion of the molecules of the gas. Use the idea of momentum to explain how molecules exert a force of the wall on the cylinder. So we're talking about gas pressure here, right? So if we are talking about gas pressure, taking all of the same notes that I would have given you all, it said here, gas pressure, molecules in a gas are in rapid random motion and repeatedly hitting the walls of the gas. At each rebound, a gas molecule undergoes a change of momentum that produces a force on the wall. Good. This constitutes to the constant pressure exerting the wall of the container, since pressure is force on unit area. Good. So they ask us firstly, let me go back to what they asked us in the question that asked us, describe the motion of the particles, motion of the molecules of the gas. Simple. We're just going to use the same exact explanation because the molecules in the gas are random motion hitting the walls of the container. That's all they want from you. Molecules of the gas are in constant rapid motion, are in rapid random motion, are in rapid random motion, hitting and repeatedly hitting walls of the what? We're not gonna say container because it was not container. It was the walls of the cylinder. We're gonna use the word cylinder because that's what they had in the thing here, this part here. Good. So describe the motion of the molecules of the gas. Molecules of the gas are in rapid random motion, are repeatedly hitting the walls of the cylinder. Walls of the cylinder. Good. So that's the answer. That's the first part. Then they ask us now later down, if we go back to the notes, or show you to the notes here. Wait. Right. So if we go back to the notes, it says at each rebound, a gas molecule undergoes a change of momentum that produces a force on the walls of the container. So they're asking us here,
Use the idea of momentum to explain how the molecules exert a force on the wall of the cylinder. So we can say at each rebound, comma, at each rebound, a gas molecule, a gas molecule, a gas molecule undergoes a change in momentum, undergoes a change in momentum, undergoes a change in momentum that produces a force when it produces a force produces a force on the walls of the container, on the walls of the cylinder in this case, right? Simple as that. So that's all I ask here. Use the idea of momentum to explain how the molecules exert a force on the walls of the cylinder. Is basically at each rebound, a gas molecule undergoes a change in momentum that produces a force on the wall of the cylinder. Remember, change in momentum, force is equal to change in momentum over time to give you the, the force. Good? So everybody okay with this so far? Everybody okay with this so far? You can move on. Nice. Part B of the question here, they said the piston is moved so that the new length of cylinder occupied by the gas is 40 centimeter. The temperature of the gas is unchanged. Calculate the new pressure of the gas. So the only two things we're going to use here is pressure and volume. Good? So we're going to use the pressure law here. Right? And in the pressure law, we know that P1 multiplied by V1 is equals to P2 multiplied by V2. Your first pressure was what? If you go back here, your first pressure was what value here? Your first pressure was 300 and your volume was 100 centimeter by 0.12. That's the cross-sectional area. Good. So your first pressure, which is P1, is 300. Which is 300 kilopascal multiplied by what was the volume? 0.12 meters squared multiplied by 100 centimeter is equals to, we don't know the new pressure, just pressure 2, but we know that the volume would be 0.12 because the cross-sectional area of the stay the same, multiplied by 40 centimeters. I'll clear all this thing now. Right, so we know that P1 V1 is equal to P2 V2. I just did it over. So P1 was 300 kilopascal multiplied by the volume, which is, we don't need volume, which is 0.12 meters squared was the cross-sectional area multiplied by 100 centimeters. 100 centimeter, which is equal to, we don't know P2 value, but we know that the volume was same 0.12 meters squared
multiply by 40 centimeters. They had asked us now to calculate, but you see this here, this centimeters, we need to convert that into meters. So we're going to convert that into meters. So we're going to be 300 kilopascals multiplied by 0.12 meter squared multiplied by, how we're going to convert that, how much centimeters into a meter? You divide by how much? How much centimeters in a meter? Good, 100. Nice. So you're going to be 100 divided by 100 here over, which is equals to P2 multiplied by 0.12 meters squared. You're going to be meter as well. Multiplied by 40 meter divided by 100. So you're going to look at that. So when you look at this whole thing, you're going to be 300 multiplied by 0.12 multiplied by 100 divided by 100, which is 1. So you should get 56 kilopascal that meter cube by the unit. We're going to calculate for P2. But we're going to work out that since here's a multiply, we're going to divide that underneath. So you're going to be 0.12 multiplied by 40 divided by 100. You should get 0.0048 meter cube. 2 meter cube cancel. So your unit should be 36 kilopascal divided by 0.0048. Your answer should be 7,500 kilopascal. So I'm gonna just make sure I get that correct. Well, I have an extra zero here, sorry. I have an extra zero as well. Right, so it will be 0.048. So it will be 36 divided by 0.048, so it should be 750 then kilopascals. So we went from 300 kilopascal to 750 because you went from 100 centimeter to 40 centimeter, which means that you have less space in the piston. So when the piston is closer, think about a piston. When you do compress the piston, you have a pressure of 300. From the time you compress it, you have less volume. So that means the piston pressure going to increase. Good. So you have 750. You have 750 kilopascals. Everybody okay with that so far? Everybody okay with that so far? Nice. So we're moving on. I try to move a little fast because I want to finish up my classes because I have this something. So the pressure we get is 750 kilopascals. Again. Nice. They say explain in terms of behavior of the molecules why the pressure have changed. Why you think the pressure have changed? Think about it. Why you think the pressure going to increase? I'm going back to the same notes. Yes. So for the pressure to increase, the molecules of the gas are in rapid random motion and repeatedly hitting the walls of the container. At each rebound, a gas molecule undergoes a change of momentum that produces a force on the wall of the container. This constitutes the constant pressure exerted on the walls of the container since the pressure is force linear. So if the pressure is going to increase, that means what? You're going to get a smaller area. So we could say here, explain in terms of the behavior of the molecules why the pressure have changed. Pressure would have changed because pressure would have increased because the gas molecules would collide with the walls the walls with the walls of the cylinder with the walls of the cylinder more often since the area is much smaller. Good, and the area is much smaller. Why? It was 100 cm, and we now go to 40 cm. Since the area of the wall is the area of the walls is much smaller, so you get more frequent collision. Good, and this will constitute a higher pressure. Everybody okay with that for now? Right, so pressure would increase because the gas molecules would collide with the walls of with the walls with the walls of the cylinder more often since the area of the walls is much smaller. Um, this can be seen through the formula. This can be seen through the formula. Force is equals to pressure is equals to force over area. Remember that? So the smaller the area, the greater the pressure, greater the force, greater the pressure. Good. So the formula would relate to that. So that should help. Again, everybody okay with that so far? Everybody okay with that so far? Nice. So moving on. All right. They said now in this here, they said here that I'll draw shows how a scale drawing of a plane front. Figure 6 show a scale drawing of wave fronts approaching a gap of barrier. Good. They said on figure 6.1, draw the patterns of the wave front after the wave has passed through the gap. So your patterns should be like this, all equally spaced out. Is four wave front. Make sure this distance is the same distance behind the line, right? So something looking like that. Gives the answer should be that here. Nice, we're moving forward. Right, it said here, the wave approaching the barrier has a length of 2.5 cm and a speed of 20 centimeter per second. They're asking us here in the question, the wave approaching the barrier of a wavelength of 25 cm. The speed is 25 cm per second. Calculate the frequency. We know so far that the wave equation, your wave equation is this value here, is this here. V is equals to lambda by frequency.
So they're asking us to calculate frequency. So frequency is equals to V over lambda, which is equals to your V was one value. This is your V here, and this is your wavelength, which is lambda. So your V is 20 cm per second divided by your lambda, which is 2.5 cm. The cm's cancel. 1 over s is frequency, which is 20 divided by 2.5. So you should have a frequency of 8 hertz. Good. Which is equals to 8 Hz, or we could say 1 over second. Note that 1 hertz, 1 hertz is the same thing as 1 inverse second, or 1 over s. Good. So whichever one of the units you want to use is the same thing. So 8 hertz. Everybody understand how we get at? Nice. So moving on. They said now state what happened, if any, to the frequency of the water as it passes through the gap. So the water passes through the gap here, and remember we had 5 lines here. It means that it diffracted. So your answer should be what? You say what happened to the frequency of the wave? You think frequency, they said here, state what happens, if anything, to the frequency of the wave as it passes through the gap. The frequency of the wave, nothing happens to the frequency, so nothing happens to the frequency of the waves, right? So nothing happened to the frequency of the wave. Just remember that nothing happens to the frequency of the wave. It remains the same. Good, so we okay with it so far? So your frequency was 8 hertz here. Nice. So they said now, in part D of the question, they said, explain in terms of diffraction why car audio may pick up low frequency radio signals, but not pick up high frequency radio signals when the car is traveling behind a hill. Because low frequency signals have longer wavelengths. So your longer wavelengths have longer wavelengths, lengths, and is able to diffract more around the hill. Diffract more around the hill. High frequency signal have shorter wavelength, and is not able to diffract
Oh, and no, sorry, a shorter wavelength and diffracts less. Again, simple as that. So, because low frequency signals have longer wavelengths and is able to diffract more around the hill, high frequency signals have shorter wavelength and diffracts less and sorry, and is blocked off by the hill. Then nice. So everybody okay with that so far? Nice. So moving on. Right, the question here says the circuit in figure 7.1 includes an immersion heater and a 6.0 battery. What is the name and purpose of X? X is what? A variable resistor. A variable resistor. X is a variable resistor, and the purpose of it is to vary the voltage across the heater. Then that's the purpose of it. Because if you increase the resistance in the variable resistor, that means the voltage drop is going to be bigger, and bigger voltage drop, that means you're going to have a less voltage across the heater here. If you want the heater to heat more, your variable resistor, the resistance must be low. Good. So they're asking now lower down in the question, the heater is designed to work from a 3.6 supply. So if it's 3.6 supply, so this must be 3.6 volts, right? I'm just going to put 3.6 volts in. 3.6 volts. So if this have to work from 3.6 volts, that means how much voltage is going to be across here? It's going to be 6 minus 3.6 volts, which is the same thing as 2.4. So you have a balance at 2.4 across the resistor. So you're going to be 6 minus 3.6, which is 2.4 volts. 2.4 volts. So here, your variable resistor will work off 2.4 volts. The heater is 3.6. Here is 6.0. They ask us now, consider the current in the heater. They said now, the heater is designed to work from 3.6 volt supply and the power rating is 4.5 watts. So you have a 4.5 watts here is the heater. Just put in values so you can see. So 4.5 and the voltage was 3.6 you can work back. Good, so those are the two ratings. They ask us now, they said at this voltage, by considering the current in the heater, calculate the resistance of the component X when there is a current potential difference across the heater. So we know that if the heater is running at 3.6, here is 6, then obviously this value here is going to be 4, 2.4 volts, because the minus the difference, you get 2.4 here. So we want to calculate now the resistance of the heater. To calculate the resistance, we need to calculate current. So if we had to calculate the resistance, so we're going back basic formula, V is equals to I multiplied by R. We want to find R. So R is V divided by I. Good. But how we find it?
we have the V. We calculate the V to be how much? 2.4 volts across the variable resistor. How we get it 2.4? We did that just now. We talk about how we find current. We know that the power of the water heater, the heating element, is equal to current by voltage. So we can say I is P divided by V. Your power of your heating element was what? 4.5. Your voltage was how much? 3.6. So when we divide that, how much I get to be for the current? When we divide that, it's going to be, how much will I get? 4.5 divided by 3.6. 1.25 I guess. So 1.25 amps. Nice, 1.25 amps. So that's your current. So we're going to use this value now and put it in here. Good? So R is equal to V. How we calculate that V? We say that 6 minus the 3.6 volts from the water heater divided by a current which is 1.25. We get a steady value here, 2.4. Remember that? This whole 6 minus the 3.6, we get that value to be 3. We get that to be 2.4 divided by 1.25. How much I get R to be? R is 2.4 divided by 1.25. What I get? 1.92. Good. So your R value is 1.92. Your unit for R is ohms because resistance. Good. Everybody understand how we get that so far? That part of the working? Nice. So that's how we calculate for R. Now they are saying now lower down the question here. I'll get the working, so I'm gonna have to remove the working. Nice. Right, so they said here now. So we get this as 1.92 ohms, right? They said after some time, the heater is switched on, the ammeter reading is seen to have decreased. Suggest why. They said after some time after the heater is switched on. So you put on the heater, the current, the ammeter reading is seen to be decreasing. So that means the current dropping. Suggest why this happens. Why you think that the current will be decreasing? Let me go back to the circuit. The circuit here. So you have a battery supply in here. Alright. They said after a while it went from 1.25 amps, it started gradually decrease now to a value of 0. Why do you think it's going to decrease? Think about it. You have a battery hook it up to a motor. After you done play with the motor, sometimes the motor start to move slow, and eventually it start to work again. Why? What happened to the amps? What caused it to not working? Battery dying, exactly. The battery was dead. Good. So basically, the battery is run down. That's all I have to say. The battery. Not just it dying because it done thing. So the battery energy has been depleted, have been, or the battery is, I'm not creating easy terms for you to understand. The battery energy have been depleted. Alright? Good, so the battery run down in other terms, or the battery is running down. Simple as that. So either one. So everybody okay with that so far? Nice. Moving on. This is alright. Right, for the CXE students, you can just give me 15 more minutes again with the IGC students because I'm trying to wrap up the paper here before I get started with you all. Alright. So in 15 minutes time I should start with you because I know I tell you the CXE student I told you 6:45. However, I'm running a bit late with the IGC students right now. So in next 15 I should start with the paper January 2019. Figure 8, continue now. Figure 8.1 is schematic diagram of an electronic circuit controlling a lamp. And these are the outputs here. This is the output of the sensor is high when it detects raised temperature, and the output of the sensor is low when it detects raised light level. The lamp is lit when the input of the high relay is high. So we're gonna look at A and B. So we're gonna deal with this here. So this is your A here, which is a NOT gate. Right, so this is electronic circuit. They said complete the truth table by giving the outputs of A and B. The outputs here is basically output of a NOT gate. A NOT gate means it's going to be the opposite. Alright, so the opposite of the light sensor. If the light sensor was 0, it's now going to be 1. Here was 1, 0 is going to be 1, 1 is going to be 0. Because output A is the output of the light sensor. It's just the opposite. There's a NOT gate here. Right, so this is a NOT gate, which is the opposite. This one here is something called an AND gate, which means that it uses two values. The only time there's going to be on is when both of them are 1. So is the output of the temperature sensor and the output of A. So the temperature, so these two columns here we're using for this here. For this portion here, these two columns. So here going to be the output of B. The only time we're going to get a 1 because the AND gate, both of them have to be 1, the other is going to be 0. Alright, that's the AND gate. State the conditions under which the lamp is lit. When the light is lighting here, so your lamp will light when the relay gets a output of 1. When it has a relay of output of 1, that's B. Only when the output sensor state the conditions under the lamp under which the lamp lights. Good. So if the output sensor is 0, they said here, the output of the temperature sensor is high when it detects raised temperature, and the output of the sensor, the light sensor, is high when it detects raised light level. So the question here says, the output of the light sensor is high or logic 1 when it detects a raise in light level. So we're looking at this here, this whole row here. Good. For this row here, because that's how the light. So for that means to say that your output light sensor must be 0. When it is 0, it means that at a low level of light. So the first condition is there are low levels of light, or you could say it is dark. It is dark. It is dark, and so the first condition, it is dark, and we talk about the temperature now. What happened to the temperature sensor? It has a 1, so that means that when it detects a raise in temperature. So when it is dark and hot, hot means to say you have an increase in temperature. So you could put that, or you could say, low level of light, low level of light, low level of light, and an increase in temperature. Alright, so either of the answer will be fine. So it is dark and hot, or low level of light, and there's an increase in temperature. Then moving on. Suggest why B is connected to a relay rather than directly to the lamp. The purpose of a relay is to supply to trigger to allow high currents to flow. Good. So I'm going back to our notes folder to see. So we're talking about electrical quantities. So all right. So let me go with they ask you why it is connected to a relay. And what's the purpose? A device that uses a small current flow to activate an electromagnetic switch for a large current flow into another circuit. So basically, they ask us here in this question, suggest why B is connected to a relay rather than directly to the lamp to allow large amounts of current to flow to the lamp. Good, simple as that. All right, everybody okay with that so far? To allow, not gonna put a big set of explanation since you're going directly to what I went out. Good, I'm moving on. Like I've never done right? They said in this question, a plastic rod is rubbed with a cloth and becomes positively charged. After charging, the rod is held close to the suspended table tennis ball, shown in figure 9.1. The table tennis ball is covered with metal paint and is uncharged. Describe what happens to the charges in the metal paint on the ball as the positively charged rod is brought close to the ball. What do you think going to happen? This is something called static electricity. Hmm? Okay, I'll go back to the question here. Um, just asking you all want to stop here and we could finish this next class? There's plenty how to deal with the C-Sec students as well. Or if you want, I could finish it up and send it to you. Now we're going to do next class. You all okay with that? Whoever available in the IGC, just do us since. Next class, Dimitri, okay, next class, yeah. Alright, gonna take a 5 minutes break and the IGC student, the CXC student should come on. So next class we will do other paper, which is 9 to 12, 9 to 12 and 9 to 11, and continue with our paper 61. Alright, good. So pause for now, and next class we go continue.
All right, so we're gonna do now the CSEC paper, CSEC January 2019. Nice. So you hearing me now? I'm sure I hear me. Hello? Good, nice. Well, I was waiting for the others, but we gotta start with CSEC anyways. So. Right, so the question here says in number 1. Now be mindful, these are all repeat questions here, most of them. Number 1, 0.000462 newtons expressed in standard form is 4.62. And we go back 1, 2, 3, 4, 5. 5 places to the right, which is 10 to the power negative 5. Good. I'm sharing a whiteboard. Would look like, so we had 0.000462. You're moving back 1, 2, 3, 4, 5. So you're gonna be 4.62 multiplied by 10 to the power of. Since we're going to the right, you're gonna be minus, going to the left is positive. So you're gonna be 10 to the power minus 5 newtons. Good, that's how we check it. Alright, so moving on. Item 2 refers to the following measurement cylinder, which is used to determine the volume of the liquid. So the volume of the liquid is at this point here. Good, which is halfway, so it's 7.5. So your answer should be 7.5. So for this here should be 7.5, which is B. Then we go on to number 3. Number 3, 1 gram is equal to 1,000 milligram. Then 1,000 milligram is 1 gram. They said which of the following instrument is suitable for measuring the diameter of a human hair? D, micrometer screw gauge.
Number 5. Which of the following implements are designed to take advantage of a large moment provided by a relatively small force? So we're talking about here levers. That's basically what we're talking about here. We're taking advantage of large moment provided a relatively small force. These are levers. And all of these are levers. So your answer is D1, 2, and 3. These are the different classes of levers. We have class 1, class 2, class 3, or however I want the class. Then number 6, the mass of an astronaut is 70 kilograms when standing on the moon. When he returns to the Earth, his approximate weight will be, weight is mass by gravity. So the gravity on Earth is 10, so it's going to be 10 multiplied by 70. So it's going to show you. So weight is equals to mass by gravity. So you're going to be mass is 70 multiplied by 10, which is 700 Newton. Good? So that's what we mean by that. So your answer should be 700 Newtons. D, this was a repeat question for one of the years as well. Number 7, which of the following is a derived unit? Derived units are always going to be square units, cube units. So your answer is C. Any unit that is square or cube are derived units because you would have to use length by breadth, which is basic units. Good. So number 8. They ask here, item 8 refers to the following diagram, which shows the velocity time graph for motion of for a moving object. Sorry, which of the following statements about the object are true? It returns to its starting point. It has zero acceleration between time 2 and time 3. Time 2 and time 3 is true, so this statement is true here. It has zero acceleration, so we know that for sure. Is that correct? Next one, they said that the velocity at T4 is the same as its initial velocity. So T4, the initial velocity was what, T1. So yeah, it could, this one true. So 2 and 3 is true. So your answer should be C for that. So C is the answer, 2 and 3. Good. Number 4, two forces of 8 and 10 cannot give a resultant of. Your answer should be 1 E, which is 1 Newton. This was a repeat question as well. Which of the following features must be present in a stable, well-designed racing car? Low center of gravity. The reason is so that the car don't topple over when you're taking corners, all right? Question number 11. A student sets up a pendulum, simple pendulum, and finds the period is 1.7 seconds. To obtain a period nearer to 1 second, he should do what? He should C. Lengthen the pendulum. The longer the pendulum, the more accurate your answer going to be. We did this in class, so you would have an idea. So you would have been more accurate. When a ball is thrown vertically upwards and reaches its maximum height, so it reaches in the air and then it starts to drop. What happens when it reaches to the point in the air where before it starts to come downward? You get maximum potential energy and minimum kinetic energy. Good. This was a repeat question as well. All right, so you would notice that there are repeat questions right through. All right, number 13. Number 13 here they said, the diagram above represents 100 mass, which can be 100. The diagram above represents 100-gram mass, right, placed on this side at I and can be balanced at position I. If the mass is at I is to be used to balance the 100-gram, it should be what? So if it's how we find the momentum, it's going to be 100 by 10 on one side, and then you're going to have I by 10 on the other side. And we know that sum of clockwise direction must be equal to the anti-clockwise direction. So this is your clockwise direction here. Clockwise, anti-clockwise, anti-clockwise. All right, so here going to be 100 gram multiplied by 10 cm is equals to I multiplied by 10.2 cm. We want to find I, so I is 100 gram multiplied by 10 cm divided by 10.2 cm. When you work on that, you're going to get I to have a value of so it will be 100 multiplied by 10 divided by 10.2, so 98. So if it's a value of 98, so your only possible answer there is less than 100 gram. Good? So number 14. What is the unit for the moment of force? Newton meter, which is force by distance, so Newton meter. Number 15. When two bodies collide, momentum is constant. This means that the total momentum before collision must be equal to the total momentum after collision, and that's number D. So good, so that's D for that. Total momentum of the bodies before impact is equal to the total momentum of the bodies after the impact. A piece of string is tied onto a small stone, and the stone is then totally immersed in water. The tension of the spring will be less than the weight of the stone. This was a repeat question as well. Because when you put the stone in the water due to Archimedes' principle or the law of buoyancy, the weight of the stone will be opposed by the upthrust force in the water. So that's what causes it to kind of partially float to some extent. So number 16 is C. Number 17, the pressure. Item 17 refers to the following diagram. Right, refers to the following diagram, which shows a dam. Yeah, the pressure on the bottom of the dam depends on what? Obviously, going to be the the depth of the water, which is the height of the water. The higher the water, the more pressure on the bottom of the dam. Which of the following scientists was responsible for arriving at the conclusion that measured amounts of electrical and mechanical energy can be converted to potentiate amounts of heat energy? This person is Joule, because the unit for heat energy is joule. Good. So it's 18. Number 19. They said here, number 19, the heat capacity of a substance is defined as the amount of heat energy needed to raise the temperature of the substance by 1 degrees. Item 20 refers to the following diagram. In which of the containers above is the average kinetic energy of the molecules the greatest? Average kinetic energy is basically the temperature of the body. Which one of them has the highest temperature? Is P, so the answer is A for that. All right, number 21. The mass and the energy required to change the state of a substance was determined to be EH. So E is equals to MLV. If M is doubled, so E is equals to M multiplied by LV or LF. So if M is double, then E is going to be double as well. So your answer is B, it's going to be double as well, right? Number 22, the specific latent heat of vaporization of water is the energy required to change 1 kilogram of water at 100 degrees to steam at 100 degrees, because you're going from water to vapor. Number 23. The graph above arising from an experiment on change of phase states the solidification starting at Q and the liquid phase is at S. Go down. During which of the stages is the substance in the liquid phase between R and S? So your answer is R and S. C. Between R and S. Number 24. The question here says in number 24, which of the following remains unchanged with an increase in temperature? B, mass does not change with temperature. Density changes with temperature because volume changes and volume affects the if volume affects density, then density affects relative density. Mass stays constant. Which of the following most likely accounts for the fact that pot handles usually made of wood or plastic because of conduction? Why the heat travels up the metallic handle of the pan? So you use either rubber, I'm sorry, not rubber, plastic or wood. In some cases, they use other materials. A detector of thermal energy is placed an equal distance in turn from each of the four faces of a hollow metal cube full of hot water. The heating on the detector is greatest when the detector is turned towards the surface, which is B. Painted dull black. Why? Because it would absorb the most heat, so it would be the hottest. Which of the following are reasons why a hot liquid placed in a double-walled vacuum flask retains its heat for a long while? Because one, the evacuated space between the double wall reduces the heat loss, all right, due to conduction. So this is true. And the so number one correct. And we go down again. And number two, the silver in a wall reduces the loss of heat by radiation, which is true as well. Number three, silver outer wall helps to absorb heat from the surrounding. That's wrong, because it will absorb heat from the surroundings to keep it. So your answer is 1 and 2. So number 27 is A. Answer is A for this. Good. Number 28 here. Which of the following is not an example of evaporation? This was done last week. The answer is D. Why it keeps showing? Alright, so answer is D for that. Alright, a loaded copper wire put around a block of ice gradually cuts through the ice. Right, number 29. Number 29, two types of radiation, L and R, falls on a woman's left and right hands respectively. The left hand feels hot but does not become suntan. Her right hand does not feel hot, but it eventually becomes tan. Let me explain. So L is your left hand, it becomes hot and is not suntan. That's because it have infrared waves. Infrared waves are long waves, so that means that they do tan, whereas the ultraviolet have short waves, which means that they do the tanning, right? So one is infrared and one is ultraviolet. The ultraviolet one is the one that causes the hand to become tan, and the infrared does not. The refractive index of a transparent glass medium is with a critical angle of C. How we calculated that? So we would have learned that N is equal to 1 over sine C, but we don't have 1 over sine C here. How we get this one? This one is the same thing as sine, and we said that the angle of refraction and the angle of incident would sum up to be 90, which means that sine 90 is the same thing as 1 over sine C. Sine 90, if you use it in a calculator, would be 1. So your answer should be C here. Good. So your answer should be C for this. Sine 90 over sine C, which is the same thing as 1 over sine C. Number 31, they said that a ray of light leaves air and enters a glass of refractive index. So we're going back to the formula here that we just did with refractive index. N is equal to sine I. N is equal to sine I, Snell's law, over sine R. Sine R was what value? So we want to find sine I. So sine I is equals to N multiplied by sine R. N was 1.6 multiplied by sine R. Sine R was sine 27. So 1.6 multiplied by sine 27. So that's C is your answer. So the answer is C for that. Good. Nice. We move forward. The pencil point is dipped in water at a point P in front of a straight barrier. Which of the following will be reflective ray? It will be the ones that come back to the barrier. So your answer is B for that. Good. So your answer is B for that. That's the one that comes back. Because it is dipped, we are assuming that it's dipped at the same frequency, your wave would be coming back to the P as that. That's number 32. Number 33 here, they said in number 33, item refers to the following table or the list of the refractive indices for light in 4 different medium. They're asking us here, in which medium would the light wave have the slowest speed? The slowest speed would have the highest refractive index. So your answer should be this one, which is diamond. So answer is diamond in number 33, which is D. Number 34. Which of the following diagram represents the fraction of water in a ripple tank? For the fraction, it will be only 2 and 3. The other is reflection. So 2 and 3 is the answer for that. Number 35. Item 35 refers to the following diagram, which shows a transverse wave at a particular instant. The wavelength of the wave is equal to the distance of, so it's between P and S. They have that. So P and S, or the next one would have been between Q. Well, they don't have none of that. So just P and S is the wavelength. So 35 is C, which is P and S. Number 36. Which of the following waves travel only longitudinally? Longitudinally is sound wave. So your answer is, wait, sorry, longitudinally. Which of the following waves travel only longitudinally? Sound waves, right? So that's the one only A. The waves that reach a listener from a radio are longitudinal and progressive waves, because that's sound we're talking about. So your answer is sound here. sound at progressive longitudinal waves. Here, number 38. Number 38 here, they said which of the following diagram best represents the passage of beam of light through a triangle prism which is split up. So that means number 38, your answer is C. With the top part what ray being your longest. Alright. Nice. So C is the answer. Number 39. 39 refers to the following information of frequency. They ask you to calculate the information given the frequency. Frequency is 1 over t. So we have to find out the period. The period is 20. So frequency is 1 over t. So you're going to be 1 over your period. The period is this period here. So you're going to be 21 over 20 is 20 milliseconds, and mind you is milli. So you're going to be multiplied by 10 to the power minus 3. So you should get around 50. Your answer is 50 hertz. So it should be C. 39 is C is the answer. Good. Number 40. The note from a drum is louder than when it is struck harder because the sound wave produced have a greater amplitude. For it to be louder, it must have a higher amplitude. Here, number 41. What is the equivalent resistance of the circuit? So you're going to use 1 divided by equivalent resistance. You're going to use this formula. So you're going to be RT is equal to 1 divided by 1 over 2 plus 1 over 4. Use a calculator, you should get about 1.3. So you're going to put all of this in brackets here. We'll have to teach some teacher reason. So 1 divided by open brackets 1, the fraction function, plus 1 the fraction function again. And you'll get 1 over 3, which is equals to 1.33. Then the answer is 1.33333. So the answer is B for that. Good. Number 42. Number 42. This is our next repeat question. Refers to the following diagram, which shows an electrical circuit with a cell and 2 filament bulbs. Which of the circuit is the same as the one above? These two are in series as well. So your answer is C. The others are in parallel. Each one of those are in parallel there. Good. The SI unit for charge is coulomb because Q, the unit for that is coulomb. Number 44. They ask us here, which of the following is not? The keyword is not here. I'm going to highlight that. Is not one of the ways in which the strength of the electromagnet increase is A, by increasing the resistance of the coil. Increase the resistance of the coil, it's going to be difficult for you to get more current to flow. It will become more hot. So the answer is A. Then number 45, which of the following diagram represents the electric field? In an electric field, you go from positive to negative. So the answer is A. The arrows always go from positive to negative. Number 46 refers to the diagram there. They say what is labeled X and Y. So X is what? A step up because you go from 3 turns to 4 turns. So that's a step up transformer. And your input does always be a AC. So B is the answer. Step up with an AC input. That's 46. 47. An ideal transformer has
1200 ratios. On primary 600, on secondary the voltage across the secondary is 20. So we're gonna calculate that there. So Vp on Vs is equals to Np on Ns. So your Vp value, we do not know that. So Vp we don't know, but we're going to change up the subject of the problem. So Mp over Ns, here was a divided created across, the V was a divided created across, it becomes a multiply now, sorry. So we're going to multiply here Vs. So you're going to be Np was how much? 1200 multiplied by 20 divided by 600. Okay, calculate, right? So when 1200 multiplied by 20 divided by 600, 40 is the answer. So A is 40 volts. All right, take it as so far, I'm Shona. Nice. Nice. So the answer should be 40 for that. So D. 47 is D. Number 48. Sorry, after 47, 48, right? They said a glass rod is rubbed with a piece of silk and is positively charged. The glass rod became charged by, to become positively charged, that means you will have to lose electrons. So your answer is B for that. And question number 49, which of the following diagrams represents a magnetic field which exists between two opposite magnetic poles? You always go from north to south, so your answer should be C. Your magnetic fields go from north to south because they attract each other. Nice. In which of the following circuit will a lamp light up? The lamp will light up in yeah, look for the one that is in bias. So this is in bias. The answer should be number 50 should be B, because here's a positive, here's a positive. Here's positive, here's positive, here's negative in the battery. So you go through here, here's negative. So current will flow like this through the thing, through the lamp, and cause it to light. Again, so the answer for that should be B. Number 51. They said, given the following truth table with inputs A and B, output C, which logic gate does it describe? Let me think. When both switches are off, there's a 1. When either of them is off, there's a 1. But when both of them is on, there's a off. So that means it is a NAND gate, because only when both of them is on, then it is off. Good. So see the idea of a NAND gate. An electromagnet consists of insulated wires wrapped around an iron core. It works because, why it works? Because a magnetic field is produced inside the coil. That's how we get an electromagnet.
Good. Number 53. When an excessive current passes through a fuse, which of the following is the sequence of events? First thing, the wire gets hot, then the wire melts and the current cuts off. That's our fuse. So the answer is B for that. Good. Now we're talking about a fuse here. Keyword fuse. All right, we're going on to number 54. Refers to the following diagram here. What is the current through resistor R1? So we want to find the current through here. So we find the current I is equals to V over R. How we find the voltage? Voltage in parallel is same. So because we could find the voltage through here, you divide by the resistance, so it's going to be 1.8. You're going to be 1.8 multiplied by 4. That's how we get this voltage here. That's for the voltage. Divided by your resistance for the circuit, which is the 6 volts. The 6 ohm resistance will be 1.8 on 1.8 multiplied by 4 divided by 6. So you should get 1.2. Good? Yeah, I'm sure if I cut it off. Yes. So it is 1.2 is your answer. So that's 54 is A. Number 55, an ammeter has a very low resistance so that it can be placed in series with the component and not affect the circuit. That's why it have low resistance. The nuclide 23, 234, 90 thorium contains what? 90 protons, and 234 minus 90, you get 144 neutrons. So repeat question as well. They're asking number 57 of Madame Curie's work in scientific research was chiefly concerned with radioactivity. Which of the following describes two properties of alpha particles? Alpha particles are positive charges and not very penetrating. Good. So these answer. Number 59, sodium decays into magnesium 24 with the emission of a beta particle. Beta is e to the power 0 minus 1. This is how a beta particle look. You can believe beta is negative. So this is your answer here. Besides 12 minus 1 going to give it 11, and 24 plus 0 going to give you 24. For it to work over the NA. Good. Number 60, the number of radioactive nuclei present in a sample of the time t is equals to 0 is n0. Which of the following graphs best represents the variation of the time? Your answer should be D. For decay, right? Because we had done this in the graph. All right, so the answer is D for that as well. Any questions, Shona?
So you hear me?
Yeah.
The only question I have is for number 11, because with the pendulum, because I watched a YouTube video and to me what I understood was that if you put the string shorter, you'll get a shorter time. I don't know if I look
Oh,
at it right or interpreted the question wrong.
All right, let me see the question. The question here is, what's question 11 is here, right?
11, yeah.
I'm gonna go back to the question. Question 11 is said, a student sets up a pendulum and finds that the period is 1.7 seconds. Good. To obtain a period nearer to 1 second, which is a faster time than this, to 1 second, he should, oh, sorry, I make a mistake with this. It should have really been a shorter pendulum, sorry. Sorry about that, Ashwana. Hello?
Yeah, okay,
Yeah,
so no
sorry.
problem. I was just wondering, but
Yeah,
didn't want to stop your flow.
it should have been. I thought it was I misunderstood when I was going through it. I thought it was what meant to be more accurate now when they said to 1 second. Well,
Yeah.
when I realized it's a shorter time, so it really should have been 11D. All right, so sorry about that.
Okay, no problem, sir.
All right, good. You got the other solutions in 2016, 17, 18, and you got the 19. Now we're doing 2020 next week, right? January 2020.
Yeah.
I'll post the
Okay.
paper tonight, self, so you can go through it. If you're getting any problems with the paper 3, 1 or 2 questions, just send me them. Well, not the whole paper to do, but if I get problems with it, I will try to work on it for you and see if I can send them back, because usually you are learning paper 3.
Okay, because I looked at a question on paper 3, but I was lost. So then I see a mistake on the paper 1, and when I read someone get a little more information, then maybe I could attempt it. So from tomorrow, I say I was going to attempt the paper 3.
All right,
That's
good,
what
good.
questions I'd ask.
Yeah, so once if I get any problem, just let me know and I could work on the paper 3 with you. All right?
Okay, sir.
All right, now take care. Enjoy your
Bye.
night. Yeah, bye-bye.
You too.
Yeah.